All right, hey everyone. We should be live. Uh, I'm here with Ben Davidson over at Observer Ranch, and it's been such a hectic week. I know I haven't brought any videos to you guys in a week. We're gonna get right on to a lot of stuff. I've been here for 1 hour, and this is a super interesting topic for me. I'm gonna let Ben introduce himself, and then I will immediately answer the question why I'm here in Colorado, literally the day after Unconfiscatable, within a few hours after finishing the final after party, hosting it, I flew out here to Colorado to come to an event at Observer Ranch for an interview I really wanted to do. I actually only discovered Ben's channel a couple of months ago. I'm going to talk about how and why I discovered Ben's channel. But Ben, why don't you do a quick intro while I check that everything is working properly?
Sounds good. You have a lot of things to mess with over here.
Yeah.
There's a lot of devices in front of this man right now, far more than I have during my live streams. Anyway, my name is Ben Davidson. I run the Suspicious Observers YouTube channel.
I forgot so.
Could people not hear me there?
It's good, but this is better.
Can we hear me now? Yeah, so I run the Suspicious Observers YouTube channel, Space Weather News. We are here at Observer Ranch. It is actually Founders Weekend, and if you hear any noise pollution, it is from the several dozen people that are mingling around out there during what's going on right now? Social hour?
Lunchtime.
Lunchtime slash, gotcha. So there may be some residual noise. Sorry, I couldn't give you a quieter environment there.
No, 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 this is perfectly fine.
You sure?
100%.
Uh, My expertise is space weather effects on Earth, things like solar flares, geomagnetic storms, large eruptions from the sun, and how they impact our planet, not just in terms of the northern and southern lights we see in the sky, but how it affects our technology, our weather, earthquakes, human health, volcanoes, pretty much everything. In addition to that, through the study of that, which is all modulated by Earth's protective magnetic field, our magnetosphere is basically the protective shield, the interface between us and the sun. And studying how it changes over time, we've also come to have quite a bit of focus on how that magnetic field is changing. And right now, we are actually in the, I guess you could say, beginning to intermediate stages of a geomagnetic excursion, a magnetic pole flip, if you will. And all of these things are playing together in a very interesting way. That shift in and of itself has impacts on various aspects of the Earth and on us as a species. And when you tie in some of what we know already about how the sun has an impact, it's, uh, it's quite the expansive topic. How is that for an introduction?
Perfect. And now we're gonna get into the details of these topics, and Ben does have a presentation in about an hour, so that will be um, all the time we will have. So let me just start off with a lot of you guys, all of you started watching me, not all of you, most of you started watching me because of the finance and my Wall Street background and trading and investing in over Bitcoin. But what a lot of people may not know is that my initial field of study was geology. I did get my degree in geology. I've hiked the Grand Canyon several times. My specialty was not the astronomical side of it. I was a few physics classes away from an astronomy minor. I did take a couple of astronomy courses, which I found super interesting, but this was over 20 years ago now. And so this is a topic of my interest. I was a high school teacher for a year, teaching math and science, and then I wanted to make money. So I ended up getting a master's in financial engineering. So that's basically my background. And a few months ago, this was the thing that caught a lot of my attention, and it was this event, the Northern Lights in Florida. They are called the Northern Lights for a reason, and they were seen down in Florida, and this just made it so strange to me. I needed to stop whatever I was doing at the time. This was back in May, and figure out why this happened. So eventually, it didn't take me long to discover Ben's channel. This is Ben's YouTube channel, by the way. You have to subscribe to it. He's only making 3-minute videos. It's every day there's just a 3-minute video. Occasionally there is a longer format video, but as you can see, 1, 2 videos a day maximum, and they're all like less than 5 minutes each, and you get your daily information take on what's happening in space weather. Here are the other websites. Suspicious Observers with a zero.org. You can get a lot of links from here. This is, we're going to talk about this website in a minute. Also, this page was actually hard to find off of your main website, but I did eventually find it, the articles that you post.
So those ones are actually from Dr. Tony Phillips at spaceweather.com.
Okay.
But he's pretty good. He knows what he's doing, and he's, unlike most mainstream scientists, which is especially interesting because he works for NASA. He's not afraid to talk about Earth's magnetic field weakening. He's not afraid to talk about the impact of the sun and cosmic rays on our weather, on the human health. And so he's kind of the one of those leaders in the mainstream who's actually willing to say things that would make mainstream climate scientists happy. Mostly because he has a lot of autonomy. When it comes to NASA and people who study the sun, he's relatively untouchable. So he has the liberty to basically be honest as much as he wants to be, which is really good.
Gotcha. And people are already asking me about Bitcoin. This actually relates to Bitcoin a little bit. We're going to talk about it at the very, very end. I'm not going to do it now. So the way I want to do it is I grabbed a couple of your videos, guys. There's a lot of links in the video description. Ben has playlists that he calls doing the homework. I did as much homework as I could in a short amount of time. I made my own playlist from Ben's videos. So you can check that out, but obviously you can see the videos on, go to the playlist. I'm going to play a little bit of a few of your videos. This is the first video I have in my playlist. I had the Earth disaster documentary first. It's an hour and a half long, may scare some people, so I thought this was a good way to start off a playlist with just a 16-minute video. We're going to play the first 4 minutes. And then we go from there. Let me turn on computer audio and share computer audio. Let me know in the live chat if the audio is okay.
Earth enjoys long, quiet eras commanded by the slow grind of wind, rain, and geology. These periods are punctuated by a recurring catastrophe. We're coming to the end of one of these calm periods, and a disaster is coming. By combining millennia of evidence, centuries of study, and the modern capabilities of technology, we can answer the challenge to explain all the evidence of Earth's disaster cycle, and we have all the tools to track the next one. The Earth is about to do something it hasn't done for thousands of years. The magnetic poles are shifting. The strength of Earth's magnetic field is fading. There are magnetic changes throughout the solar system and on the sun. We're going to be showing you stories of this cycle of disaster that will visit us again soon. This story is told several ways, and here you're going to hear them all. We'll begin with the pole shift. It's real, and it's going to happen. In fact, it's already happening. There are major magnetic pole shifts every 12,000 years called geomagnetic excursions. There are even more minor events on the 6,000-year half cycles. The China event was just confirmed earlier this year. The most well-studied events are the last one, 12,000 years ago, the Gothenburg geomagnetic excursion, and an exceptionally powerful one about 40-something thousand years ago, called Le Champ. It's the same for other events. You can find information on all of them when you search the science journals. This happens very regularly, and it has already started happening again now. The Earth began its magnetic shift in the 1850s, but it has progressed more since the year 2000 than it had in the 150 years or so before. The shift is accelerating, and will keep accelerating. These events coincide with major climate shifts in the past, volcanic events, and biosphere stress that results in the extinctions of species. After the scientific field went back and forth on this topic for decades, the conclusive study was performed in the world's #1 geophysics journal. These magnetic excursions take out several species and cause serious stress on the entire food chain. through not only volcanoes and climate shifts, but extra space radiation, navigational issues with birds, mammals, and marine creatures. These shifts can happen very rapidly. In fact, if the next one happened tomorrow, it already wouldn't be the fastest one in history after having been ongoing now for more than 150 years. When it reaches peak acceleration, it will be shifting 100 times faster than today, or more, and we'll just have months left, maybe weeks. This is a story with 1,000 pieces, but they come together to tell a scary future for our planet, and it's told in the rock, sediment, the fossils, and the cooled lava. Let's next address the fact that this event seems to be hitting the whole solar system, and let's further take a step out to the galactic level very quickly. The galaxy has a rippling electric current sheet, just like stars, our sun, and like energized sphere magnets in a lab. In our galaxy, the wave height, the amplitude, and the wavelength have been analyzed, and based on a speed of around 600 to 800 kilometers per second of outward radial flow, they should be hitting our solar system about every 12,000 years. This current sheet contains the galactic magnetic reversal point, not the galactic equator, as incorrectly is believed by many. It is this galactic magnetic reversal, expected about every 12,000 years, that is impacting our solar system, and which is the driving force behind the overall 12,000-year disaster cycle of Earth. Up next, what about those?
Okay, so I'm going to try to do this in sequence. Everything at the highest level is being driven by this galactic current sheet. Can you just briefly explain that?
Sure. It doesn't matter if you've got a spinning sphere magnet in a laboratory here on Earth, or if you're looking at any of the stars we can see, or if you're looking at the galactic level, not just the Milky Way, but they've discovered this in other nearby galaxies as well. There's three main components to the electromagnetic central engine, and that is jets going north and south, a torus, basically a donut of plasma around the equator of the central object, and from the equator of that torus, a rippling wavy current sheet. This contains the magnetic reversal point of the system, as well as, in the case of a galaxy, it contains extra plasma, charged particles, extra dust, and extra neutral matter that is swept up with it. And so basically what getting hit with this galactic current sheet means is your solar system is taking a galactic magnetic reversal, a dumping of dust and plasma and gases into the system as well. And so from an electromagnetic and a chemical perspective, it has significant effects on the local star, the planets, the interplanetary space, etc.
And you believe this, like the dust, the rippling of the current sheet, hit us in 1859, around that time, that set off one of the biggest, well, in our recent recorded history, a major event with solar flares, the Carrington event.
Right, and it's important to realize this current sheet is not like a singular point in space. There's some thickness to it. And so the leading edge of it arrived at our solar system probably about 1859. In that year, the sun released a super flare, the only one for the last several hundred years. And that was also the very same year that Earth's magnetic pole shift really began. The magnetic poles began moving faster and faster, and the magnetic field strength protecting our planet began weakening, and that's been accelerating faster and faster. The big moment will happen when we come to the exact middle of the current sheet, which is where north becomes south, south becomes north, and the actual galactic magnetic reversal occurs. What we've had so far is a slightly changing electromagnetic situation, but not yet a reversal, combined with extra dust, extra plasma, etc. And so we've started to take the effects of this current sheet, but not yet had the actual galactic magnetic reversal. That's when things get pretty scary in the solar system.
Right, and people are already asking, like, so if we can't do anything to stop it, why do we care? We're gonna get to that because humans have survived this every single time, and we will get to that topic after you guys have a better understanding of what exactly is happening. I'm gonna play another quick clip, and because I kind of got them in sequence. So let's do one more clip, maybe about a minute or two. Wait, did I not have this at the right spot? Usually not this bad. There we Okay, and one more clip.
It says that they're not seeing the video.
My fault.
Electric age was raised, literally, to the
Can we
ground,
just go
as
back
the
a little
cure
bit?
to happen, and
Yeah.
offer our best constrained timelines for each. The listing of the events and their timelines is most helpful, but only with the appropriate understanding of what each actually is and its significance. So let me tell you a story first. Before any of you were born, the leading edge of the galactic current sheet arrived at our solar system. It began what will finally present a 10% change in interstellar density and the galactic magnetic reversal. The sun announced the arrival with a superflare. Early solar scientists tied a massive sunspot group to a geomagnetic disaster unheard of at the time. In 1859, the virgin electric age was raised, literally, to the ground, as the Carrington event solar storm surged electric current through the planet that would not only set telegraph wires on fire, but would induce the beginning of the modern magnetic excursion of Earth. The Earth's field began shifting, the climate began warming, the magnetic field began weakening, the poles shifting faster and faster. It would be more than 100 years before we'd realize that the other planets were changing too, seemingly accelerated of late. And we would wait just as long to learn that the stars in line with the center of the galaxy were performing record outburst activity, one after another, in a line, right at the sun, and were next. It would be 2020 before we learned that the sun's coronal magnetic fields were reacting, and the chemistry of its atmosphere was beginning to change, most notably in the helium. Thus far.
Okay, so I want to put up the screenshot of the events in sequence. So the other thing that is shown in that video, and I would have a picture right here. I have two of these pictures. So we'll get to that too. So in 1959, around that time, our magnetic field started to weaken, and it lost approximately 10% of its strength in over 100. It took over 100 years. This weakening of the Earth's magnetic field has started to increase, and this is one of the reasons why this is happening, is because the poles are moving and they're not able to protect the Earth in the same way.
That and they're actually becoming weaker themselves. It's not just that they're alive, it's that the actual magnetism that they are able to surround the Earth with is decreasing in a very significant way. And as this image shows, it's happening faster and faster and faster as time goes on.
And this used to be published by NASA or one of the other government agencies. And after they saw that everyone can see how quickly the Earth's magnetic field is weakening, they stopped publishing the data.
Right. They have not given us any new data on exactly how weak the magnetic field has become since 2010, but we can use other things to extrapolate, whether that's there's actually a change in the auroras, the northern and southern lights, their intensity and where they're located. There is a number of changes that are happening to the ionosphere, which is the highest level of the atmosphere. That can be tracked as well. And so we can actually use some of the other Earth layers and how they changed from the 1800s, 1900s to now, and then seeing how much they're changing at present, and be able to extrapolate how much weaker the magnetic field is becoming over time.
And while the poles are, while the magnetic field of the planet is weakening, the poles are shifting, as you guys heard from the video. And right now, this is where we have the North and the South Pole. They are moving, starting to move faster. Sometimes it looks like they're moving erratically. But some consensus between multiple scientists, I'm not sure if Einstein is one of the ones that also mentioned this, that there will meet in the Sea of Bengal between India and Malaysia. And when that happens, this would become the new North. Well, we'll get to the Earth tilting 90 degrees later, but this will eventually become the North Pole, and this on the opposite side around, looks like Peru over there, becomes the South Pole. And this is happening at the same time as it gets closer and closer. Our next topic, again in sequence, we'll get to it in sequence actually. This should happen around the same time as a potential micronova, but we haven't gotten to that yet. Okay, so this is what's happening with our planet. Now let's shift to what is happening with the sun. And for those of you that may not know, the sun does have one of these polar flips, and I think it's every 11 years.
Yeah, 11.
So it's on the sun. Well, nobody lives on the sun, so it doesn't actually affect us living on the sun. But this website, this is Space Weather. This is a government website. And if I scroll down here, and it is, which one is it? The solar cycle progression. This was part of Ben's presentation yesterday. And this is the short-term look. And this is also in the thumbnail. Let's expand this back a little bit for the last 70 years. These are solar maximum and solar minimum. Ben, can you explain this chart a little bit before we dig into this a bit?
Sure. Well, as you just mentioned, there's an 11-year magnetic cycle on the sun. Every 11 years, the sun's magnetic poles flip. And when that happens, there's a number of things that happen on the sun. Features known as sunspots and coronal holes actually switch hemispheres. It's not like the sun actually does a flip, but some of the important features on the sun actually flip. The outermost plasma layers on the sun actually flip which hemisphere they're operating in. And this is the same time spots, a lot of solar flares, and it's when we're likely to have the aurora when this chart is high here, denoting that it's sunspot maximum, given the fact that solar flares can only happen from sunspots. There's more sunspots at solar maximum. That's what throws the particles out into space that give us the northern lights and the southern lights.
So this chart tracks the number of them, not their strength, correct? Or it's their strength also?
So it sort of depends. Like having a sunspot counted on this chart doesn't tell you anything about the size of the sunspot or if it's flaring. However, in general, the higher these curves go, the more sunspots there are, the greater the chances there are for those solar flares. And so the answer is sort of yes and no, if you're asking, does it tell about the strength?
Gotcha. All right. Oh, let me just check. Let me just drop this. Let's put this here. No, the other way. All right, that should be better. All right. Sorry, guys. And our last cycle did not have a lot of sunspots, but the increase in sunspots does correlate with increase in solar flares
Yes.
that are gonna come at Earth. Now, if I take this back to, let's say, pre-1850, this chart is pretty consistent. Looks like the worst ones were around 1960, the most number of them, and that Carrington event took place in 1859. Now, during the solar maximum, where we are right now, this has the highest potential of hitting the planet with a solar flare. And if that solar flare is strong enough, it has the potential of wiping out our modern day technology. And the problem when this is coinciding is it happening at the same time as the Earth's magnetic field is weakening. There is potential over the next 2 years that one of these solar flares, basically several of them that would have been unnoticed in the 1980s, those same ones that would be like a mosquito, are now could be very, very serious and very critical to our modern day infrastructure. Do I have that correct?
That is absolutely correct. And so that's one of the reasons why this ongoing magnetic pole shift is so important, because we are seeing things just like what you mentioned with the northern lights seen in Florida. They were actually seen in Puerto Rico. They were seen in New Caledonia, near Oceania in the Southwest Pacific. They were seen way further than they should be. But the issue is that we've taken much larger blasts than that from the sun, and they haven't produced the same kinds of effects. And the reason why is because the further you go back in time, the stronger Earth's magnetic field was. And it really isn't until you get into the last decade or so that we've really had such an acceleration, such that we can now look at what the sun is throwing at us and say, okay, the sun's not doing anything special or anything unheard of, but it's having relatively unheard of effects on our planet. And the reason is because the magnetic shield that is protecting us from the sun is getting weaker and weaker. And so eventually we're going to get to a point where the magnetic field is so weak that the normal random solar activity is going to act like a super flare. And when that happens, it'll probably throw us back into the Stone Age in about 1 day.
All right, we will touch upon that topic a little bit more as to how best prepare yourself for that as well. So right now in the short term, we can get lucky and go past the next 2 years where the sun activity would slow down, but the magnetic field is still weakening. So just because there is less sunspots with the weakening of magnetic field, there's still some risk, but the most risk is actually over, probably over the next year. We're not going to get into the topic as to why, for some lucky reason, this entire cycle of the last several years, the big solar flares are happening on the back side of the sun or on the side of the sun. So there's been some solar flares already this cycle that could have potentially caused major disruption to our modern day technology, but we were lucky that they were either grazing blows or went on the opposite side from the sun where the earth was not touched by those flares.
Yeah, that's happened a couple of times. The storm you were talking about, where the northern lights came down to Florida in May of this year, if that had been just a little bit stronger, there would have been major power disruptions all over the world. If it was modestly stronger, it could have sent us back to the Stone Age. But about a week after that event, those same sunspots that had caused the flares had turned around to the far side of the sun, and they unleashed a solar flare that was 10, 20 times more powerful. If that had hit Earth, we wouldn't be having this conversation. There'd be no internet. There'd be no electricity. There'd be 1 billion people dead already, if not more. due to the lack of infrastructure and water purification and water distribution and the ability to grow food and the ability to transport food or heat homes, other things like that, the ability to refrigerate food. It will be a complete disaster when this happens, and we came very, very close just a few months ago.
All right, and on that note, let's move over to what could happen after that. So again, there is a sequence of events here, and this is where, uh, so at solar minimum, this is where the sun is not ejecting all that much. And as the galactic current sheet is coming, it could potentially surround the sun with, I guess, interstellar dust, which, if the sun isn't able to inject it away from itself, now we could see the sun go a little bit dim, which is your indication that something bad is about to happen within a week. And that's when there is a potential for a solar micronova, which is something that when I was studying astronomy and geology was not even a concept. And now it's becoming more and more papers are coming out that those 12,000 year catastrophic events that wipe out species and basically continents, if you are the unlucky one whose continent is in direct path of the sun, this micronova event is instant. At the speed of light will make the sunlight hit Earth about 8 minutes. It's actually one of the things I definitely remember from 20 years ago. It takes 8 minutes for the light. This is all like barely in the early days of the internet, so you couldn't just Google this stuff. You have to like remember some of it. And so the micronova event is more likely to happen during a solar minimum, not a maximum, even though it can certainly happen at any time. And that's the event that potentially wipes out half the world if you're the unlucky one on not half of the world. And the solar flare that could wipe out electricity could happen the week before, or it could happen a decade before. So this is a concept that I try to break down these topics as a former teacher. Can you just elaborate on what I said? And if I get something wrong, immediately correct me.
It all sounded right to me. I was paying attention more to some of these
You don't want to do that.
I know. It reminds me of my own live streams where I basically just end up making people look stupid the entire time. Like the person who is like, I feel good in the sun. I feel much healthier. I don't believe this fear shit.
You're in the sun all day.
I'm in the sun all day. You shouldn't be afraid of sunlight. Like, you got 2 ears, one mouth. Act accordingly. But no, it's things we didn't say, just making stuff up there. Yeah, I'll admit I got caught up looking at the chat.
All right.
But no, what you said is absolutely right. The sun, it would have a very hard time shooting off a micronova at sunspot maximum because it's got the energy to push all that dust away from it. Not to mention extreme ultraviolet and X-ray light to photo dissociate dust and other matter as well, literally break it apart. It's probably the most terrifying well, I would say it's one of the two most terrifying aspects of this, the fact that you can't answer all of the geologic evidence without something like a solar micronova. As we were talking about a little bit yesterday, galactic physics doesn't match actual observations of the galaxy and this electromagnetic wave unless you have these micronova events injecting energy into the current sheet, puffing up its buoyancy, sustaining its buoyancy throughout the galaxy. And so from both a Earth evidence and a galaxy evidence perspective, you have to have these kinds of events. And then you think about what mainstream science even says makes a star go nova. There's two things. One, dump a bunch of material onto it, or two, have some kind of major magnetic kick or disruption. Well, it's going to have stuff dumped onto it at the exact same time as it takes a galactic magnetic reversal. That's literally the two ways to make a sun go nova, happening at the exact same time. And it's the only way to explain the evidence at the galactic level and here on Earth. That many coincidences from a scientific perspective are not something to be ignored.
Right. So let's go back to the timeline of events. There are two major catastrophic events that are coming. And if you're unlucky and you're in the wrong area, or, well, if you're in the right area and you get lucky, if you're prepared and you get, we're going to talk about the preparedness part. Now, there is still a luck factor. So yes, you can be as prepared as possible, but if the Earth is not in your favor as it's rotating during the micronova, there's probably nothing you can do. That's one catastrophic event. The other catastrophic event we haven't discussed yet, the 90-degree tilt of the Earth, and there's two leading ideas as to how it can be. We're going to briefly mention them, though I will say for the youngest millennials, the most catastrophic event is going to be the solar flare a decade earlier that wipes out their TikTok. Now, that one is absolutely survivable by anyone and everyone, and that should give people, it's impossible to say, right? But anywhere from a week to 20 years of a heads up. And at the moment that happens, everyone is going to know that this is not bullshit. So that can happen actually at any time. So again, for those that really wanted me to cover the price of Bitcoin first, Bitcoin is not exactly going to be functioning, so I'm saving that one for the end for those of you that stick around, because during this conversation, starting this off with where the price of Bitcoin's going is not exactly ideal. The solar micronova event can happen soon or 10 to 20 years following one of these solar flares, and that one is also borderline luck-based when that solar flare could potentially wipe out the electricity with a weakening magnetic field. Then, as the poles continue to meet in the Sea of Bengal, around the time of the micronova, but probably not before the micronova, right? Most likely soon after the micronova, within hours, days, months, maybe a year, but unlikely before, but possible before the Earth flip.
Really, the main issue.
I have to, because I'm unlocking the crust.
Yeah.
Yeah, we're getting to that. Yeah,
You need something like the micronova to actually unlock the crust from the mantle, because it's not like a piece of plywood sitting on a lake and it can float around and it's disconnected. There's a tiny area in between the rocky crust and the
You
liquid
know what?
mantle.
Let's play this video and then we'll explain it. So here's one more of the videos. What would happen with the pole flip? And I'm going to run out for a second and get a prop. All right, should be working.
Mechanism of how the Earth tilted over 90 degrees from that magnetic pole shift. It looks like this: a 90-degree tilt, then a tilt back about 12,000 years later when the cycle happens again. It is already underway now, 12,000 years since the last one. Now, there is another layer to this piece of evidence, but first let's review. Almost every ancient culture and religion describes these events. My favorites are from ancient India, the Book of Enoch, the Bible, and Zoroastrian texts. They are supported by the geologic evidence of great floods triggered when the oceans wash over the continents as the Earth turns over. The mammoths could not have survived in the polar region today, and definitely not in a glacial cycle. The old ice argument fails twice, by isotope problems and by the fact that glaciers remain in the tropics today. And then the classified data and scientific reports from Project Nanook, the Pentagon, and RAND all point to the same thing. The Earth turns over 90 degrees. Now, the easiest way this happens is during the Great Solar Flash, which is also evidenced as part of being in this disaster cycle. Modern solar storms are proven to induce electric current all the way down into the mantle, and when the big one happens, the solar flash, the crust will be unlocked from the mantle due to the geochemical changes below. RAND, the Pentagon, Chan Thomas, Einstein, and many others did the math and checked the evidence, and they all say that the Earth would tilt such that Greenland would shift southward to the equator, and the side of Antarctica just south of Australia would shift north to the equator. Now, this would put the new geographic poles near India and near South America. Remember that. Now, I said this is underway again at this time, 12,000 years since the last one. The magnetic poles have already begun to shift, well ahead of the Earth turning over, and they are actually on a collision course with each other near India. If we presume one would stay at that location, and the other magnetic pole would pop out the other side of the Earth, then the 90-degree tilt that we have described in this video would put those new magnetic poles right back to the geographic poles from the model that was classified, which also happened to be very close to the Bermuda Triangle and Dragon's Triangle magnetic anomalies, respectively. So how many coincidences are we supposed to ignore?
Okay, so real quick, as I was prepping for this morning, I do have a question. Is that a potential new continent?
No,
What am I missing here? Oh, is that
it's mostly ice up at the north.
Oh, so this would be the north?
Well, so the current,
Because that's Alaska here, and that's Russia here.
yes,
So what is this?
that's ice.
That's ice. So this would be the
Like if you dug all the way down through that ice, you wouldn't hit land, you'd hit ocean. It's like the Arctic Ocean. Like so, for example, let's just
Oh, this is today. This is what it looks like now.
yeah, that's what it looks like right now.
Okay. Oh gosh. Okay, so that's Greenland right here.
That's Greenland.
Oh, okay. That's like currently ice. Yeah, because when you look at a flat map, you don't really see this. Okay, I mean, okay, that's Greenland. I do know my. Oh wait, why did my camera go out?
It's okay. You can still hear us,
Yeah.
right?
Oh yeah. Audio's fine. I don't know why the camera went away. So no, but I do need this prop in a second. Let me get my camera back up, and Ben, anything else to add onto the video that people just watched?
Presuming they were able to comprehend everything I said at what do you have me there at 1.5 speed?
1.5, 1.25. I usually do it faster, but people watch me at like 2x, so I only did it in 1.25.
Yeah, so I mean, I feel like reiterating that is important because all right, so if you prefer the mythological, the religious texts, they all say the same thing. Catastrophists from Cuvier, Deluc, Leibniz to Einstein all agreed there's no way to explain the evidence unless the Earth turns over. For those who are more inclined to look at the modern science, you showed that book, World in Peril. Project Nanook, which is still mostly classified. Luckily, the head of the project, Major Maynard E. White, had the foresight to save all of the classified data to give to his son to publish in that book. So we know that in the 1950s, the Pentagon and the Rand Corporation together figured out the Earth turns 90 degrees, then the Earth turns back. And as if, saving that classified information wasn't enough, I briefly mentioned the mammoths in there, but we didn't get too deep into it. That mammoth thing is important because think about where they found the mammoths in the Arctic Circle today. These mammoths had to eat 1,000 pounds of vegetation or more every day to survive. There's not that much vegetation there right now. And we're 12,000 years into an interglacial warm cycle. They got frozen in a glacial cycle when it was even colder than it was today. So there's no way there was enough vegetation there. The answer is they were eating in around mid or low latitudes, somewhere in there. And then the Earth tilted and all of a sudden they found themselves at the polar region.
All right, so here's my prop, right? This is a tangerine, mandarin, I don't know, they're all the same to me. It's an orange, same stuff. And so I actually heard or read, I'm not a reader like you, so Ben, you're a speed reader and you have close to a photographic memory.
I have mild hyperthymesia.
I'm the complete opposite. I can listen at like 2x speed and comprehend and memorize or watch stuff, but I still read at an 8th grade level. Like I'm good with numbers. This is why I have 3 STEM degrees. But reading is I've read 3 novels in my life. This is the level I'm at. So complete opposite. So the way I heard of both of these is the theory of Atlantis. It was a very modern ancient city. Some kind of catastrophe happened, and some of the one that makes the most sense to me is that it is under the ice in Antarctica. This is of course debatable. But ice aging is also very inaccurate. And it's also possible that a part of Antarctica has had ice for a long time, and a part of Antarctica was actually nice and tropical. And if you believe that Atlantis is buried under the Antarctic ice, and Antarctica was at one point near the equator, there's 2 ways this can happen. One of them is literally, this is the Earth, and it just flips 90 degrees, and one of your other videos explains how this might happen. That's one potential theory. The one you believe is a little more accurate, from me doing the homework of watching his videos, which I recommend you all do, is that the solar micronova, the electric current that would go through the planet, would unlock the crust. So imagine this orange, where the top layer of the orange, the one that you peel, is not actually connected to the orange itself by those little white fibers. And it's the main part of the orange stays the same, but the peel of the orange, the crust of the earth, shifts 90 degrees in order to reorient the north and south magnetic field. And I heard about it's called crustal displacement. And you can only imagine what kind of volcanoes or mostly earthquakes that would happen. So think of that movie, not Day After Tomorrow, which actually is a movie that I liked back in the day, 2012. And in 2012, I believe, they didn't say which one it was, but I think it was crustal displacement.
They did, but they used Charles Hapgood's like 7.5 degree tilt, which would still be disastrous, but we know that his version of it was actually wrong. Some interesting ideas about that, actually. But
Yeah, we're not going to get into the mantle liquid or not. There's so many other things we have to talk about. We only have about 15 minutes. Yeah, so those are the two potential theories. There could be more. Something else could happen. Again, no one was there back then. So we don't know what really happened, but these are two leading theories. So this is that second catastrophic event. So the micronova, if you are on the sun-facing Earth, you're almost screwed unless you have a proper underground bunker. Maybe you can get lucky, but then what happens to the food? That's a whole. We're gonna do rapid fire set of questions on that. If you're not on the sun-facing side, and for some reason, that also tends to have a cycle where the last area that got hit badly by this tends to survive the following few cycles. And the last area that got hit the worst by the solar flare was North America. So this is Graham Hancock's things. I don't watch that documentary. I just don't have the time. But I do believe something horrible happened in North America 12,000 years ago. That's why we wouldn't have any large mammals. That's why they couldn't domesticate any animals. That's why Europe developed so much faster in the last 12,000 years versus North America. So this time there is a higher probability that North America is going to be spared, but I'll let Ben fill in the blanks here.
well, I mean, you said that pretty well. For reasons we don't understand, but we can see very clearly from the pattern, no two areas of Earth take the worst of it, so, in back-to-back cycles. It seems to be ticking around the Earth, kind of like a hand ticks around a clock. And, it'd be great to know why, but we don't. We just know the pattern very clearly. It's not unlike how our ancestors long ago could literally predict eclipses to the day, but they also thought that the moon was alive and jealous and capricious and could get mad at us for things that we did. So they didn't really fully understand what was happening, but they knew when certain things were going to happen because they recognized the pattern. It's not a universal thing, but there are some situations where identifying the pattern can allow you to be predictive even if you don't fully understand why the pattern is the way that it is. I would say it is the minority. That's not the majority of science, but this is one of them. The one I just gave you, the example with the ancients predicting eclipses, is a good example. And this example of how we can tell which continent gets hit the worst during these cycles, looking back into the past. And it's never the same cycle twice in a row. And like you said last time, North America took the very worst of it.
And this time, your best guess, and it's pretty much is a guess, is that Asia will probably get the worst of it, like Southeast Asia to Asia.
The eastern part of Asia will get the worst of it this time.
Okay.
Sorry, Japan.
Yeah. My co-host on my financial channel literally just moved to Japan, back to Japan.
Scary, man. Scary.
Okay, few more clips, and we're running up to the end of, nope, not that one, this one here. So right now we're talking about that stage 7, and this is once the Earth does tilt, we're gonna get massive tsunamis, and this is where we're heading next with these little clips. Oh wait, screen share. I got it this time.
Degrees from that magnetic pole shift. It looks like this, a 90-degree tilt, then a tilt back about 12,000 years later when the cycle happens again. It is already underway now, 12,000 years since the last one. Now there is another layer to this piece of evidence, but first let's review. Almost every ancient culture and religion describes these events. My favorites are from ancient India, the Book of Enoch, the Bible, and Zoroastrian texts. They are supported by the geologic evidence of great floods triggered when the oceans wash over the continents as the Earth turns over. The mammoths could not have survived in the polar region today, and definitely not in a glacier.
Actually, I think it's literally the same thing as from another video. Let me play this one. Yeah, here we go.
One of the most difficult to believe aspects of the Earth disaster cycle, which will reset in the next 25 years, is the Earth flipping over. But alas, you cannot explain the evidence without it, and the physics says it's possible. We have shared many times the new orientation of Earth after the flip. This is how our planet will look and rotate in the aftermath of the catastrophe. Old polar regions at the equator, new poles near India and South America, and continent-sized tsunamis as it moves there. We have described in detail that our preferred theory for this is a crustal unlocking from the mantle in the solar micronova event. Induction breaks the thermoelectric bond between them, and the crust slides free. But we have also gone over and do fully recognize the possibility of another alternative, the Cherenkov effect, the tennis racket theorem, or second axis theorem. In fact, despite our preference for unlocking the crust to be this mechanism, we made 2 videos on the Cherenkov effect in 2019, 5 years ago. Given the theory's recent resurgence into the internet, we figured it's time for a quick review for all of you here. So here's where this begins, the spinning object in space. This can be done with any object spun around an axis that is not symmetrical, like a tennis racket or a hammer. There are periods of stability and rotation punctuated by a rapid flip, and then a recapture of stability for a while before another flip. Now this concept was the focus of a video by Veritasium. Very cool channel, but he got this one wrong, because his entire premise was that this couldn't possibly apply to the Earth because we don't have the same dynamics and structure. He said that Earth is symmetrical about our spinning axis, and well, that is just not true. If Earth looked like this, I mean, actually looked like...
All right, we'll pause it there because I don't want to move on to how this is survivable. But I'm not familiar with that channel. It sounds like it's a big educational channel on different topics. But the fact that Earth's not symmetrical, I mean, maybe because I have a geology degree, that's just common knowledge, right? Sort of. Quasi.
It is. I have no idea why. I mean, he's a very smart guy. Some of the stuff that he does is like PhD level stuff. But this one he got completely wrong. He demonstrated all the ways that a spinning object can flip over and flip back and flip over. And then he said it couldn't possibly apply to the Earth because the Earth is symmetrical about its second axis. Not only can you look at the oblate spheroid shape of the Earth, or the ocean basins, or the mountain ranges, and know that's not the case, but inside of the Earth, we have something called the large low shear velocity provinces. It's like a handlebar type feature that comes out from the core and fingers up all the way into the crust. And so in literally...
What's the weight of the ice at the poles?
There's in no way can you look at the Earth and say we are symmetrical about our second axis. It just doesn't work.
And even itself, if you take a basic physics course, like even College Physics 101, they'll tell you that the Earth is not even a sphere. It's a little bit compressed at the poles.
It's not even close to symmetrical about the second axis.
Okay, so just a couple of things before we move on to what to do now. A couple of things I forgot to mention, and we're going to hit those now. I haven't shown you guys this picture, not that we're going to discuss it much. Normal magnetic field, excursion. Well, we're not this bad yet.
No.
But this is where it's going when the poles meet. And you can see what kind of protection we have. So this would be the sun-facing side.
Yes.
The more protective side. And this is what happens on the sun-facing side when the magnetic poles are about to flip. And this is why a solar flare that would be unnoticed 40 years ago can next week potentially wipe out our electric grid. Don't be too scared. I'm still planning to travel. I don't have my bunker yet, but it's one of the reasons why I'm here. We're going to talk about bunkers and how deep they need to be in a second. We'll do rapid fire questions on that. One more quick thing that we haven't mentioned is we're seeing, I asked you this question during your presentation. We're seeing, well, scientists are paying attention to this, are seeing the effects of this on all other planets. Venus is a little tricky because of their super thick atmosphere, but all other planets are noticing crazy change in their climates and their weather and other factors, even more so than the Earth is. Like the Earth's weather is changing, its climate is changing, but it's happening even in a higher degree on other planets. Just briefly comment on that.
Right. Whether you're looking at the sun or you're looking at any of the other planets or you're looking at the interplanetary space between the planets, there is evidence that this is not just happening to Earth, it's not happening to the Earth and sun. It is an entire solar system shift, which is exactly what you would expect from that galactic current sheet. And the evidence of it can be seen out past Pluto and at every major sphere coming all the way into the sun.
We do have a good question. How long does it take for the Earth to move 90 degrees?
About a day.
Yeah, hopefully it's a little slower than that. But yeah, it's going to be.
Here's the thing, even at a day, the peak acceleration you need in one direction is 17 miles per hour per minute. And so imagine changing your speed by 17 miles per hour, but it takes a whole minute. You experience far greater G forces every time you stop at a stop sign. It's just that force applied at every moment for hours on end is what drives the oceans into the continents.
Right. So that's what creates giant tsunamis and massive hurricane wind speed.
Yeah, and I would say that it's important to use the word hurricane because, some past books have talked about the potential for, mile-high tsunamis. No, it's going to be more like a high tide that doesn't stop all day. It's going to keep rising and rising. It's not going to be one giant wave. It's not going to be a.
So it's like in the movie Day After Tomorrow, where just this one high wave went into Manhattan.
It wouldn't be like that.
It would be even slower.
It would be much slower than that, but it would last for hours, and so it would. You could be standing there on the Gulf Coast, say in Mississippi or Alabama, and all of a sudden you look down, you've been standing on a beach and the water's at your toes. And 1 minute later, it's halfway up your shin. 1 minute later, it's approaching your waist. And so it's the kind of thing where it's not a giant wave, it's a slowly rising tide. The problem is after hours and hours, if you're anchored to that beach, the top of the water is going to be 100, 200 feet above your head. And so that's the main tsunami thing. And that's also something that has to apply to the wind when you think about it. Now, hurricane force winds, sure. 1,000-mile-an-hour winds. One, the math doesn't suggest we would get that. And two, if that's the kind of thing that happened during these cycles, it would scour the planet. There'd be nothing left. And as bad as these are, even in the worst one we know about, which was the Lechamp cycle 40-something thousand years ago, only like 3 or 4% of the species went extinct. And yes, sure, other species took a 20 to 80% reduction in their population. It's still a horrible event, but there'd be nothing left if there was 1,000-mile-an-hour winds or a mile-high tsunami on every continent. It's not quite as extreme as somebody like Chan Thomas wrote in their book, not quite as extreme as the movie 2012. Or things like
We'll get to that in a second. So
what are you doing?
We'll get to that. Chan Thomas, this is the Adam and Eve story. For those of you that are like me and aren't readers, I guess you can watch the Y-Files episode on this. I think he did.
I would prefer my videos on this. The Y-Files didn't do a good job.
It is entertaining though.
Well, yeah, he's going for entertaining. I'm going for absolute truth.
Yeah. So I need to watch your videos as I have not seen your videos on this. But that's how I became familiar with this from the Y Files episode, as I'm sure a lot of people did become familiar with the Y Files episode. Okay,
I'm
and
screwing up again, dude. I'm reading the chat here.
no, don't read the
I'm
chat.
screwing up here.
Go to the chat and so one more thing we didn't mention during the solar micronova, especially one of the big issues you got to deal with is lightning. And I kind of knew this because I read or saw it somewhere like a decade or two ago. But when you tell it to people, you sound crazy. Lightning goes from down to up almost as often as it comes from up to down, right?
Yeah, and the down to up is going to be a lot more prevalent after the micronova, and as the crust is shifting, because we've taken the Earth capacitor has taken in a bunch of energy. The static buildup from the crust moving and the oceans moving is going to be fantastic. There's going to be a lot of discharging of the capacitor that needs to occur. Hope it doesn't happen beneath your feet.
Okay, and now we're going to move on to what can we do and why. I mean, is this survivable, right? And you had some awesome answers, mostly during your Q&As that you do, as to we've survived this every time.
Every time.
And do a little speech on that as I pull up a couple of screenshots that I have of potential survivability zones.
Well, sure. Yeah. As I mentioned before, even in the worst such disaster, there's always one continent that gets hit worse than the others. And humans are now spread all over the world. Makes it much harder to wipe us all out. But also the fact that this happened 12,000, 24,000, 36,000, 48,000, 60,000 years ago. We're still here. And it's the kind of thing where, okay, massive megafauna, as they call it, they're the most vulnerable. They're the ones who are, honest to God, only able to survive because of relatively stable environmental conditions and their massive size. And, either being apex predators or not having to be afraid of apex predators. During an event like this, that's when the megafauna, the bigger, dumber animals are most at risk. The smaller, smarter creatures, craftier creatures, more adaptive creatures, they're the ones who are more likely to make it. And, I could sit here and crap on human decision making all day long, but the fact of the matter is we're not a dumb species. We can be adaptive. We've survived every single one of these before, and that's not going to change now.
All right, so the number one question is how best to survive it? Well, I'm sitting here with the expert who has, over the last 3 to 4 years, or maybe a little longer, has built Observer Ranch, which is, I'm here for the 2-day event. This place just opened about a month ago, and I literally discovered Ben's channel a few months ago, guys. And I know a lot of you are smarter than me. I know I have a little bit of a background in astronomy and geology, but I've learned a lot in the last 2 months while still, bringing you financial content every day, still traveling, putting on a conference. This is definitely learnable. And this is one of the zones that you believe is one of the safer zones. From me watching your videos, you believe that it's very possible that because the Earth would tilt, I guess, swing this way, that the water from both Atlantic Ocean and the Gulf of Mexico is going to move up into the continent, but the water from the Pacific side will have a tough time getting over the Rockies, which it did 12,000 years ago.
Right, because that's the one thing we notice is the tsunamis are going opposite directions every cycle as the Earth tilts one way and tilts back, tilts one way, tilts back. That's going to send the waves in opposite directions. Now, last time the Pacific attacked, but that's not going to be the case this time.
If the Atlantic attacks, there is don't assume that the Appalachian mountain chain and the Adirondacks are gonna stop this rising tide.
No, because last time, while the peaks of the Rockies stayed dry, you know, mountains have valleys that cut through them. There are low areas. The Pacific did break through the Rockies and dump some sediment that they found in, in the Gulf of Mexico, for example. There's sediment that didn't come from the Gulf of Mexico or the Atlantic. It is a mixture of sediment from the Pacific and sediments from the Rocky Mountains that got washed all the way down there. Now, the waves are coming the opposite direction this time. And so,
Right. So you want to be away from the water and at high elevation, and your ballpark estimates is you take your elevation in feet and you add it to the number of miles you are from the ocean. So sitting here at Observer Ranch right now,
we are exactly at the 1 mile elevation mark, and we're hundreds and hundreds of miles away from the nearest ocean. So here, where we are in on the eastern range of the Rockies in Colorado, we are in the blue. We are in the safest area. But the top line there is the equation. How many miles away from the ocean are you? What is your elevation in feet? Add those two numbers together and then see where you are on this chart. And that bottom one, prepare to float, there's a reason I called it that. And somebody astutely said it in your chat a minute ago. So what, buy a boat? Yes, because it's not going to be a mile high wave. It's going to be a fast rising high tide to the point where if you're moored somewhere, or even if you've got an old boat sitting on some kind of track in your backyard, it's just going to be lifted up and taken away. Now, it's important not to have something like an inflatable raft because there's going to be trees, rocks, cars, glass, metal, shards of wood, all kinds of stuff in the wave, all banging against one another. But it's the kind of thing where either get up high or prepare to float.
so it's actually interesting. So I'm not so in those, stories of Noah, where he's building this ark like in the middle of like I'm looking out the window. You guys we can show you guys what's out the window after. But it's like nice as like Colorado plains here with the mountains in the background, and you build this giant boat here on land, and you're sitting in the boat, and the tide would lift it up. You don't actually need it on the ocean.
It doesn't need to be on the floor.
So we are like 1,000 miles from over 1,000 miles from any ocean here. Probably, yeah, probably about 1,000 miles away from not 1,000, about 500-600 miles away from any ocean. And you plan to build a giant boat here, probably just in case, right?
Just in case, but it's definitely lower on my priority list
Right.
because, I mean, I know which way the waves are coming. It would be hard pressed to get here because the waves are not coming directly in this area. They would literally have to, against their own inertia, decide to make a 90-degree turn and then climb an entire mile uphill over about 300 or 400 miles. And that's just not
Right.
going to happen. That's not how physics works. That's not what water does. So,
So Ben views this as one of the safer zones in North America. We're only going to go through 3 continents here. I believe you have some documentation somewhere on the whole planet.
yes,
Zones?
somewhere, but a lot of it is,
Very
a lot of it isn't as detailed as the look at.
Yeah, Europe's probably not ideal because of the massive volcanoes in Italy.
Camp
Don't have,
Flegrei is horrifying. Yeah.
don't have time to get into that. Some parts of Spain, maybe some parts over here in what do we got here? Northern, right above Greece. This area here. And if you're in Australia, maybe somewhere in the middle of the
Yeah,
continent.
see, here's what I mean about being less detailed. That area on the left here, that's got the big circle, that's going to be safe from the tsunamis. But as I understand it, that's basically badlands. There's basically no living there right now. And so it's kind of like, okay, well, are we doing a all things considered safety map, or are we looking at a am I safe from the tsunamis map? And so you could have the best location in the world. If they've got the population number and the cultural demographics of, say, Denver, Colorado, cross it off the list. Doesn't matter that Denver, Colorado is never going to get hit by the wave. It's not going to be rocked apart by earthquakes. After the flip, it's got a pretty good climate. but it's Denver. There's a couple million people, and for those who don't know much about Denver, there's a lot of that population that is the whole pink hair dye and
Right.
facts don't matter as much as your feelings kind of people. So not exactly the kind of folks you want around during this disaster.
All right, so quick summary on where you want to be. Stay away from big cities, stay away from the ocean, stay away from fault lines. So California, definitely no good. Japan, right off a fault line. Uh, you want to be in high elevation. You want to have underground potential. Can we talk about that? That's a big question, right? Like how deep underground? And I had a bunch of questions when I was watching
You don't need to be very far under.
like it's like, oh, how deep underground do we have to go? You have those caves in Derinkuyu in Turkey, which I find super fascinating. They were big enough to hold livestock and everything. And of course, ancient aliens will claim it's because, like aliens are looking for them. But a cave system like that is interesting.
Yeah, and stuff like that could work, but you really don't need more than a root cellar. You just need to be able to be under the ground where you've got some protection. I see somebody wrote DUMBs, and that's a dumb idea. DUMBs stands for Deep Underground Military Bases. You get too deep, the seismic activity, the lava motion, and the electrical induction of the event will destroy you. I would be willing to bet that more than 90% of the DUMBs, the deep underground military bases, are completely destroyed during this event.
So it's interesting. So I came out here for two reasons. Well, I came out here for the main reason was to chat with Ben. By the way, you're gonna have an awesome documentary coming out soon. There is a videographers here. I wanted to contribute a little bit to the documentary, and the other thing is, it just so happens that in Colorado, a few hours drive from here, I know a person that recently purchased. I actually didn't know the term DUMB. Thanks for explaining it to me. Deep underground military bunkers. I know somebody with a deep underground, I don't know if it's deep or not, but it's a military bunker, one of the biggest that can house like 1,000 people. And I wanted to go and look at it before coming here and talking to you, but I'm going to see it after. But since I've been just watching a bunch of your videos over the last 2 weeks, I'm like, I'm not sure that bunker is a good idea. But that was another reason why I was coming out here. And it just so happens that it's driving distance away from where you are. So the location is good. I'm going to go check it out. I may bring you guys a video from this military bunker. And if it's not deep enough, or I'll see how it is, and if it's worth your time, maybe you'll drive up there sometime later this year.
Maybe we'll see.
I'll do the scouting report on this first.
Yeah, it's important if you're going to build your own bunker, you don't do it in a place like Los Angeles or in a place like the Mississippi River Delta. No, you need to have elevation. Otherwise, you're either going to be covered up with water or the waves are going to push sediment. And, you go to open the hatch and there's 30 feet of mud and sand and muck and trees on top of your door that you're not going to be able to pop off. So, there's, get away from cities, get to high elevation, and have a way to hide underground.
So the other two geographical areas we didn't discuss, middle of Africa is probably okay, but if you're not not native to that land, it will be tricky. Most of the people watching us are Westerners, so I'm probably not going to be going to the middle of Africa, even though I kind of like Africa for survivability, and maybe Central Russia.
Central Russia could be okay. The main thing you also have to worry about is, let's say we get that solar flare that knocks out all power a decade before the Earth turns over. You have to look at your weather right now, and whether that's the heat of Phoenix in summer or the cold of Russia in winter, and say, okay, if I don't have any electricity for 10 years, and I can't rely on going to the store or getting firewood delivered. I have to do everything myself, and the weather is slightly worse. Will I be able to make it? And so that would probably be the main question for, say, Central Russia. It's like, okay, yeah, it would be survivable.
Yeah, it might be cool after the the flare. But you don't want to move there now because survivability there right now is a little bit tricky. And building out your perfect place to, whether it's a 10-year gap between the potential solar flare that knocks out electricity and the Earth flipping over.
Right.
So that's the one thing you need to consider. So Antarctica, sorry, if this happens the way Ben's expecting it to happen, and Antarctica is now at the equator, after a few thousand years, that could become a nice place to be, even though we're not sure that 12,000 years will be enough to melt all the ice.
It probably won't be. 12,000 years probably won't be enough to melt all the ice. Don't forget, we have glaciers in the tropics today, 12,000 years into an interglacial warm period. After this ends and we go into the next stage of Earth, it'll be a little bit more glacial conditions. So it's going to be colder. And so there's no way you're going to melt all of Antarctica in the same amount of time.
Okay. So as part of your preparedness for this, it's not just, you also have to work on your body and your mind. You have to be mentally prepared and you have to be physically prepared.
Okay, fine, do it.
Time to talk about this. That's used 8 years earlier.
Yeah, so I'm actually, and that picture was taken last year. I actually look significantly better than that now. I'm turning 40 in 4 weeks. Yeah, I used to be extremely out of shape and not tremendously healthy. Things have changed. Carnivore diet, counting protein, counting calories.
Too? I am. I'm carnivore plus fruit.
Why?
I really like fruit, and that's my best cheat, but I fruit selectively, like raspberries.
So you're not carnivore, you're primal.
Sure.
Primal diet.
Okay, that's a good way. I haven't heard too many people say it that way. Yeah, I'm carnivore plus fruit. I need to be a little more religious about it, but that's what I do.
The number one primal diet guy in the world is in the next room.
Oh, really?
Yeah,
Please introduce me to him.
he's the old dude with gray hair and the buzz cut.
It's like 3 of them there.
No. I'll point him out.
Please. And wait, so hold on. So you're 40 now. You're turning 40. I will not be able to make Ben's birthday here because the day after that I have a wedding to attend. So this was what happened? Why isn't this opening? There we go. So this was me at 40, and I don't look like that now, but this is what I look like at 40. And I lost some. I went backwards. So I gotta step it up. But that was me when I was 40. And that was like right before the pandemic. I'm giving away my age here now. Okay, we got a couple of rapid fire questions. And these were the questions that I had. And after watching enough of his videos that are in the video playlist that I gave you guys, these questions were actually answered. Now, I always thought that if the world loses electricity for 6 months, we all die from nuclear radiation because all the nuclear power plants would melt down. They really only have a 2-week to a 1-month power reserve to keep the nuclear reactor going, and you don't believe we will die from nuclear radiation?
No, it'll be an issue. You don't want to be living right next to one. But look, Fukushima melted down. Nobody died of radiation poisoning in Japan. They, on day one, started doing testing on every single fish caught from the Pacific. They have never yet once caught one fish in the Pacific that had more radiation than a banana. If you smoke one cigarette in your life, that's more radiation than you'd get from eating Pacific fish every day. Now, granted, they did do an evacuation around Fukushima. You wouldn't want to be right near a nuclear power plant when it went off, but you also have to remember a lot of this will get washed into the ocean, rained out of the sky. It's not a good thing, but it's not the end of the world.
Now, the other thing is, as a geology student, I went to the Yellowstone volcano. That's another one. My first, when I saw that you were building your observer ranch here, I'm like, wait a minute, he's way too close to Yellowstone. That's a giant supervolcano, 600,000 years ago. Lava flows made it all the way into Oklahoma. And you're not concerned over Yellowstone either?
No, are you asking for everybody else, or have you seen my Yellowstone videos?
I did see it.
Okay, so
I'm asking for them, but I see it.
Yellowstone is very, very broken. Very broken.
Yeah.
It's the only volcano in the world that can boast their level of pressure release. From their earthquakes, their geysers, to geothermally, it has no way to build up pressure. And so you could have what's known as an effusive eruption, which is like what Hawaii does. You know, the lava comes up and it bubbles over, and, you know, sometimes it spills out a good way. But there's that kind of effusive eruption versus an explosive eruption, which you need to be building up every ounce of pressure you can for thousands and thousands of years. Yellowstone has no way to build up pressure. It releases the pressure every time pressure starts building up. And so it's an effusive threat. You don't want to be 50 miles away from Yellowstone directly downhill. But that whole explosive destruction from the movie 2012, no, it would need to
Right.
change.
These were actually my two biggest questions I had coming here, but thank God I watched enough of your videos as I was, the week before I came here, that these questions were answered. But to me, they were very important questions. You already covered how deep underground and how long underground. Just summary, not that deep, just enough from direct sun impact, and how long. Could be as little as a day, could be as long as a few months. Your best guess, right?
A couple of days.
Okay.
Couple of days.
Now, this was a really interesting one. How to protect some electronic devices, how to protect metal. Metal might melt during this event, Faraday cage versus plastic containers, and everyone is going to ask, well, can I hide solar, panels that when everything comes back, can't I just put my solar panels back up?
Okay, so we'll take those one at a time. One, I prefer plastic containers to Faraday cages. Faraday cages have an inherent failure point. Plastic is just a barrier that electricity will want to avoid. It'll want to take the path of least resistance. The problem is that once Earth's magnetic field gets to that level, and let's say we lose all power, the magnetic field is still very weak. What if you get another one the next week? You're like, oh, the world lost power, time to pull out my solar panels. And then we get hit next week, and the week after that, and the week after that. And so there's really no way of knowing when Earth's magnetic field will be up at peak strength, or in the case of the solar micronova, when the super flaring aftermath of the micronova will be over. And so there's really no way to know when you're safe to pull those solar panels out and actually hook them up, provided you could even protect them in the first place, which is questionable.
Right. And for people that have metal in their body, I heard you mention you have metal in your teeth, so do I. We're of that age. Even like any metal in your body is probably something to think about.
It is, unless you're literally a half robot skeleton, you're probably going to be okay. Things you can do are making your body energy field healthy. Our bodies have an energy field just like the Earth does that protects us and mitigates things, but it's based on our physical and our mental health. And so this is where I really hate that somewhat woo-woo topics have to invade this otherwise scientific and mathematical masterpiece concoction. But it's absolutely true. Your mental health, healing your traumas, positive attitude versus negative attitude, these things all affect the electromagnetic fields of our body. It's not just, okay, do we eat McDonald's or do we eat fresh food every day? So everything matters. Literally everything matters now, which is not what people want to hear, as we are literally dealing with 18 different levels of clown world in the economy, culture, politics, and everywhere else.
Yep.
Literally everything we're doing behind the scenes for ourselves matters as well, from physical health to mental health to staying informed about all this and not completely losing our minds.
All right, and we didn't touch upon it, but like solar cells and energy, actually you did just touch upon it. Your body also has a magnetic field around it.
Right.
Man, I just have one final question in my head to close out. Oh, here's why. So when I was on a call with Ben, and I am over his time already. When I was on a call with Ben, my initial thought was, man, like I travel for, you stopped flying years ago.
Yeah.
You don't get on a plane.
No.
What's the main reason?
Um,
Oh, the solar flare could happen
a
anytime.
combination of cosmic radiation penetrating more due to the weakening magnetic field and ever increasing likelihood of a plane crash due to diversity, equity, and inclusion quotas at places like Boeing.
Oh yeah, I've talked about that on my channel.
Holy crap, what are they thinking?
Oh yeah, did you see the United, who I usually fly? They was literally they're hiring based on that. Yes.
Yeah.
Yeah. So for those, and you don't want to be far from your family when this happens.
Correct.
For any chance. So you're always within a short. No, if you have to, you can jog there.
Right.
And so, man, okay, so here's what it was, right? So in my phone call, like you guys know, I still want to move to a little tiny island in the Caribbean and open my tequila bar. And one of the things I said to him, man, I'm not gonna drop everything and start building my bunker. I'm just gonna enjoy the last decade or two, and hopefully Ben's wrong, and we have, past my lifetime here. And so I was just gonna do it. But then it was something you said on your video, and this is where I really want to close it out on. And what Ben's, I have one final question. What Ben said, I remember the final question. What Ben said was that really resonated. He said, if you know and confident this is going to happen, and you have the means and the ability to survive, you owe it to humanity to try and survive. You said this in one of your videos. You should probably say that more often every now and then.
Maybe, but that's one of those things that goes in people's ear and out the other.
It really resonated with me.
I'm glad. You're one of the rare ones.
That part really resonated.
Most people at this stage of this conversation, they're thinking things like, what happens to nuclear plants after a 1 mile wave? Even though we just discussed nuclear plants, and I just discussed a little bit before that there won't be a 1 mile wave.
I'm gonna defend Turip. He is a moderate. It's possible.
I can see that.
It's possible he's not watching us live. It's possible he started watching this on a delay and he hasn't caught up yet.
That is true. It's not going to stop us from throwing down the salt, though.
Bro.
That's what I do.
So that's more likely I'm not answering. And yeah, so it's not a selfish thing to try and survive this. Just so people know. And we're not going to talk about the elites in their bunkers. Okay, this was our final question I wanted to ask you before that. Do you think prior civilizations were more technologically advanced than us?
In some ways, certainly. There's evidence.
Like levitating, like anti-gravity technology, but maybe not going to Mars.
Maybe I'm thinking in terms of some of the things they were able to do architecturally, that may or may not have involved things like being able to reduce the gravity through resonance or frequency, harmonics, vibration. Some of the great stones may have been cast, certainly not all of them. There's this one ancient temple in India with gigantic pillars where when you hit them, they all resonate at a different frequency, and we have no idea how to do that now, given the fact that they're made of granite, not metal or anything. So I think there's probably been civilizations at our level or further advanced, and they all went back to zero and started from the starting block. So.
All right. Thank you so much for the extra time. I think we covered all the topics I wanted to cover. We're not going to be able to get to a lot of your questions, guys, but you have to watch as many videos. If I can watch those videos, so can you guys. And there is a playlist in my video description. If that's not enough, and it won't be enough, go to Ben's playlist of older videos as well. A new documentary is going to come out. And he's doing 3-minute updates every day on what is going on with our sun. Any topics we missed, and that's it.
I would say the only other thing is come see us in person here at Observer Ranch, observerranch.com.
Yeah, check it out. Come and visit. Meet Ben in person. You post which days you're here, and you don't live that far away, so you're here quite often. And eventually, you'll be living here very soon once the infrastructure gets built. Okay. All right, guys. Thank you all so much for watching. This has been a really fascinating topic for me, doing a deep dive in the prior 2 weeks before coming to talk to Ben. I did my homework. It's time for you guys to do your homework. All right. Thank you all for watching. And now you know why there's no need to talk about Bitcoin because once this happens, we're going to enjoy it while we can. I'll be exiting at the top of this bull cycle, and I'm sure others will as well. Monday morning, back talking finance and trading. We do have to pay our bills somehow. Thank you all for watching.